bring on Stella Tkatchova, EIC Program Manager for Space Systems and Technologies. Stella! How are you, Stella? Good to see you. The stage is yours. Enjoy. Looking forward to hearing from you.
Hello, everyone. So, it's a pleasure to have you here and to talk about our EIC space portfolio. So, I would like to share some insights about our space portfolio. SMEs and startups are changing the global space industry. Today, competitive driving forces are dominating the industry. Numerous launches of satellites, reusable launchers, in-space servicing and extension of lifetime of satellites. So, clearly, space exploration has brought numerous benefits. For instance, many of you remember that Apollo missions resulted in the development of more than 42 products, such as kidney dialysis machines, insulin pumps, wireless headsets. Today, navigation and SATCOM communications are essential to our daily lives. Optical, radar, and thermal infrared instruments are actually giving us essential data for monitoring climate change, fires, deforestation. We have almost 12,000 satellites in orbit. There are unprecedented opportunities for SMEs and startups to develop technologies for active debris removal, for in-orbit satellite servicing, for wireless power transmission of solar energy, and space propulsion systems. Yet, startups have a number of challenges. Space SMEs need to design, test, and successfully fly their hardware, and in parallel, attract customers and investors, and even rely on non-EU launch capabilities. Today, it's very important, however, to look at the long-term future. Mastering the use of in-space resources like solar energy and space debris will change the way we perform space exploration in the long term. Let's start with solar energy. Clearly, there is a need for clean and renewable power for satellites using energy. Through the collection, conversion, and transmission of solar energy in space, using it for in-space propulsion, we can access renewable energy and achieve strategic autonomy in space. So here is the Repower-SIC project, which you can see. They're working on a high-power laser transmission. It's a Pathfinder project from our portfolio. By using solar energy for in-space propulsion, it could become much more autonomous. So here is another project. This is the Ice to Trust project, which is aiming to develop solar electric water propulsion using water for propellant, using hydrogen and cutting in on oxygen. Just imagine how the use of solar energy will change the future of space exploration. Powering lunar rovers on a lunar surface, using solar energy for in-situ resource utilization, or performing in-space mobility and orbital correction using this energy. Now, but there is a big threat that is called space debris, and most of you have watched the Gravity movie and are aware of that. Current satellites are designed, built, and launched in space not to be serviced or repaired. They easily become space debris. Debris might collide with operational satellites and cause serious damage on satellites or endanger astronauts on board the space station. But they can also become a hazard for human population, air and naval traffic. Today, in 2025, we have more than 30,500 objects in space, leading to increased collision avoidance maneuvers of satellites, shorter lifetime of spacecraft, and growing costs for operations. There is clearly a long-term need for green, compact, and interoperable technologies for space debris mitigation, removal, and in-space recycling. So, imagine if we can develop these capabilities and have robotic arms, nets, harpoons capturing space debris, or having tethers, space lasers, which actually remove debris. Imagine if we have recyclers capturing this debris and in space recycling it. So, here are some more examples of some of these projects for space debris sustainability. We have the ETPAC project, using electrodynamic tethers to remove space debris. A project we just started as an idea from the Pathfinder and now is in transition as they created their own spin-off. However, in our EIC space portfolio, we also have many others, like the Supreme one, using high-temperature superconductors for electric propulsion. Or other projects like manufacturing solar arrays in space, or ones developing power conditioning units using their own manufactured semiconductors. Of course, we shouldn't forget propulsion technology, electrospray technology, ionic liquid electrospray propulsion. It just launched on the 14th of January, 2025. In our portfolio, we have more than 35 space projects, but we have more than 7 launches in the last 2 years. So, clearly, future space exploration will be driven by technologies such as micro-launchers, modular satellites, orbital transfer vehicles, all developed, tested by SMEs and startups. We are clearly witnessing the emergence of many new space companies in active debris removal, in orbit satellite servicing, in space mobility, and in space refueling. But it's important in the long run to master the use of solar energy and space debris, because they will change radically the way we perform space exploration. We'll have access to infinite energy and contribute to space debris sustainability. So, space missions are a cradle of technology innovation, space technology innovation. Thank you very much.
Thank you, Stella.
Thank you.
Fantastic.